Again, guys, hello. One more time, I will repeat what I understand. The final, it says the final for daytime and evening time is supposed to be different, and perhaps truly was supposed to be different, but you all were emailed the same link, the same registration, and you all appear under the same gradebook. Do you see? 73 students that registered from both sections are all together. I do not imagine that the system can distinguish between daytime students and evening time students. Do you understand? So I think the system will think that all of you are daytime students, because this Math 112 exam that I have here will open up between 1 p.m. on Tuesday, December 15th, and close at 3:30 p.m. unless you had special permission, you see? So I only see one copy of the exam. So I assume that due to clerical error, which I did not detect in time, for that you have to forgive me, right? I place my hand on the chopping block, and I will if I have to, but because of this clerical error, you are all morning students, right? And because you're all morning students, your exam is from 1 p.m. until 3:30 p.m. If it is inconvenient to you, if you cannot take it at that time, you can email Professor Suzuki, right? But again, the department is extremely loaded. This person, I feel bad, I feel terrible even sending him hello, you understand? Because you cannot imagine how it is to deal with just 2 classes or 3 classes. Imagine dealing with all the sections combined. It's incredibly intense. So that's one thing. Secondly, it's not only because I want to spare the person, it's because I think that you are confused when I say the exam is at 1 p.m. and you say it's a different time. So I am expecting the confusion to be even worse if I say something else. So again, because it is something new and because the clerical error was detected late, you should assume that your exam is at 1 p.m. If, guys, do you understand? If for some reason I'm wrong, and then the evening sections will have the exam at the times that it's mentioned here. Although I do not see it here. I do not see that the exam will be available at a different time. Please confirm that you understood what I said. Okay. You can email if you have time conflict or you have a lot of problem with this, then email Professor Suzuki and you will have a different time slot. Good? Sort of. Well, Alan, what do you not understand? Sort of means that some of you do not understand something.
No, it's just that, like because we are in evening class, so
Yes.
like I thought that we would have it like in the evening, like 6 to 8.
Well, welcome to bureaucracy. When you study with me probability theory, then you are made to read Kafka so that you understand what bureaucracy is like. And if a paper says it's morning, then it doesn't matter. It's morning. If it says summer and it's the winter in the Arctic region, then it is summer. Okay, that's as simple as that. This thing, it says that you will take it in the morning. Now look at a very simple example. I told you when I was mentioning about the exams to email me the exam writing E if you're evening student or M if you're morning student, last name, first name. About 10, 20 people did not do that. It's a simple instruction. So can you imagine what would be if I switch, right? If I switch, if I start saying, oh, if I add anything else. So it's very simple. You will take the exam in the morning unless it is in the evening. Do you understand? Right? I see that the exam is in the morning. If I am wrong, that means you open it up and you see, oops, it is in the evening. And you take the exam there. If you are thinking that it's going to cause you some tremendous stress and problems, then you email Professor Suzuki and you will have the makeup exam on Friday. Exactly. Understood? But I am not going to change it at this stage because I do not want to create a new section. I do not want to re-register you for, for this thing that can create more problems than it's worth. Take the exam at this time if you do not have a time conflict. If you do have a time conflict, take the exam at a different time. Notice, this is all I see, guys. Do you understand my point? I do not know when your exam is, just as I know it as much as what this message says. I see the final will be available at 1 p.m. until 3:30 p.m. If my brother is actually going to, I'm hoping he will give me that a file for Human Giant so that I will make you understand even better what is happening here. Okay? All right. Any questions? The exam is in the morning unless it is in the evening for the evening students. And for the morning students, it is in the morning. Is everything clear? Beautiful. Now let's begin with the review. Practice questions. How you practice the questions, guys? Practice questions is the most important thing you can do, because the exam, as far as I can tell, based on my conversations with the higher ups, with the people living in the castle, in the ivory tower, is that the exam will be 16 problems out of, oh, you got it. Thank you so much. Here, no? You know what I have, guys and girls? I have this very great explanation about the exam, so that nothing is confusing, the infomercial. Okay, so I will mention that after we solve a few questions to relax you a little bit. Okay. All right. So let's begin with this. What is it? Okay, are we there? Have you practiced the problems, guys? Let's begin. And by the way, show me your faces, because I look at your faces and I see how you understand. If you understand. All right, so we will begin with the last question first, with question number 50, and go upwards, so that we do a little bit of integration. All right, here is your first problem. Let's see if you can do it. I'm gonna wait maybe at most 2 minutes for you to solve this, and then I'm gonna show you how I solve it, okay? Bring your paper and pen. Can you use calculator? I presume you can, but you don't need a calculator. You need your brain. Okay, so yes, here it's an open resource exam. Here is your problem. You have 2 minutes. One more minute. Okay, Lisha, good. We'll see in a moment what the answer is. Good, Minkowski, you made it. All right, time. Now, what is this thing? What operation do we have here? Capital F, its derivative is little f. Do you see that? So very simply, what is this? This is reverse chain rule. Reverse chain rule. So what do I have here? The reverse chain rule is that, look at it, the antiderivative of this function is what? The antiderivative of this function is the, well, here I'll just do it separately. I'm sorry. So it's this thing, right? I can write it like that. Look at it. This line tells me that I have a perfect chain rule. So the answer is, well, it's to the power 4, yes. So the answer is this thing to the power of 5 times 1/5. And I have to evaluate it from 3 to 4. So I put 3 here and a 4 there. You understand? If I can find, that's the fundamental theorem of calculus. If you spend time thinking about it, fundamental theorem of calculus tells us just figure out the antiderivative and evaluate it at the bounds. So that is 1/5 the expression at 4 raised to the 5th power minus here minus 1/5 the expression at the 3rd power. So it would be f of 3 to the 3rd power. Good. And the result is what? So the result is 8 to the 5th power. So it's 1/5 8 to the 5th power minus 4 to the 3rd power. Good? You understand how I did it? So you see you have whatever videos and here I can put it, maybe, let's see how I put this information. You see it's 1/5, 8 to the 5th power minus 4 to the 3rd power. Yes, I'm sorry, my brain is in the morning, I didn't sleep. It's to the 5th power, you're absolutely right. Thank you for noticing this glitch. It should be to the, that's why if you put work, a computer is not gonna care for such mistake. I understood the problem, solved it essentially right, but I wrote to the 3rd power where it should be, you see, it's just because I glitched here and here, right? It should be to the 5th power. Good? So then how do I put this information in? I can write parentheses, I suppose 1/5. Here I can write, what is it, 8 to the 5th power minus 4 to the 5th power. Yes? Good. So I finished and now I submit my answer. And what do you know? I was correct. And here is where you put your work. You saw show detailed solution is you can add work. So that's when you would write it on a scrap paper, but hopefully in a good one that I can read. And yes. Good. You understand, guys? And here you can add work. You can either blah, 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 type something, or show detailed solution. I don't know. That's yes. So you can upload some work over here if you want to. Good. All right. Onwards. We solved problem 50. I understood how I did it. What's wrong, Alan? I said it says I'm right. How can it be wrong?
I checked that, and even though I did it exactly the way it is, it says it's wrong.
Ah, well, that's why if you put some work, I would be able to see what you did. And if the computer says it's wrong and I say it's right, then only what I say counts. Good. So you guys, you understand how to do this thing, right? How you can submit this question. You can type something here. Yes. Good. So practice uploading solutions and doing that thing as well, so you don't have trouble when the time comes. If you, for some reason, have solutions that you could not upload, but you have those solutions, you can send them to my email, okay? So do not be stressed, okay? If you have...
I tried.
Yes,
Sorry.
relax. Relax.
Still answered the correct answer, yet it still was wrong.
Well, I do not know what happened over there, but look at it, guys. You write those questions on, let's say you have the scrap paper and you write on a neat separate sheet of paper, neat, so I can read it. You see, don't torture me. Some of you do torture me, right? I want it neatly done. You can write it on a separate paper, and even after the timeline, if you, some reason you're too worried, you can send to my email your PDF file, but you make it neat, okay? You can take more than 30 minutes, but make it very neat, like the exams that some of you submitted. Some of you submitted like separate pictures, which slows me down tremendously. By the way, some of you cheated, but that's another story, right? Yes, of course the cheating was stupid, and you didn't with the cheating get a very good score, but you know. So I'm still grading, right? And I'm seeing similarities. Anyhow, so do you follow what I'm saying, right? Write your solutions, and afterwards, if for something, if you're too worried about your submission of this exam and you're not able to put them here, you can still have the option of placing them in my email. But when you do that, you make it very neat and beautiful. Organized. Good, let's go to the next question, yes? Question 49. All right, it's your turn. Now you have 2 minutes. 2 minutes. Okay, good. A few of you solved it. They might be randomly generated, Alan. I don't know. It's a website. So give me
Yeah,
a
you're
sec.
right. Maybe that's why it's. Oh, it's because it's a different question. Never mind.
No worries. You have until I finish downloading Human Giant to solve this question. Okay. All right. Now let's continue. All right, we had plenty of time to solve this question, and you are absolutely right. Look at it. How can I represent this question? Well, this is the integral of the derivative of this function divided by the function. So it's a perfect chain rule. Do you see that? So the answer is ln of capital absolute value of capital F of x evaluated from 9 to 10. Yes? Now I plug into the function, I plug 10. Be careful, you see it's a bit confusing. 9 is 10 and 10 is 4. So that should be ln of f of 10, which is 4, minus ln of 10. You agree? It's ln 4 minus ln 10. So let me now input this into the system. So I write ln of 4 minus ln of 10. Okay, now let's see if the solution is correct. Okay, great. I solved it correctly, right? Here I can add work if anything. Good. Next question is question 48. It's now your turn to do it, guys. You should do it in 2 minutes. I think you can insert image, but you see, I haven't actually bothered going through this thing. So make sure when you practice that you can see how you can submit your work. Okay, if you are worried that something is not right, make sure to gather your work and write it neatly. You can submit it through my email. I will check that in case something is not going right here. Time's up. Let's do the problem. Ready? Okay, let's do it. So the human giant, I will show you. I was not ready to do it right away, but it's a very, very pertinent. So what is the answer to it, guys? So you can obviously see that that we need to only find the antiderivative of which function. Would anybody kind of scream in your text at once? Of which function do we truly need to find antiderivative here? Of cosine. Beautiful. So the answer is, let's annotate it. So the answer is simply sine of this capital F of X evaluated from 7 to 8. Agreed? From 7 to 8. So what is this? This is going to be sine of, at 8 it's minus 4. So sine of minus 4 minus sine of 3. Agreed? I don't need to simplify it further. So let's put this information here. So it's sine of minus 4 minus sine of 3. Submit. And what do you know? I did it right. Beautiful. Yes, you don't need to worry. Don't do more work than you have to. Okay, guys? And let me tell you something is that for some questions, if I see that you did it, you know, well, I will not be too bothered about the work, but make sure you have the work and you can put it at a separate, you know, you can add it here. And if for some reason you're worried that something doesn't go through, you keep the work, you can send it to my email. Okay? Most likely, yeah. So anyhow, let me not make you too nervous. Good. Question number 47. All right. Do not attempt to find the formula for f of x. Go ahead, solve this silly question. Okay. So this, you have 3 minutes. I'll give you actually 4 minutes, right? 4 minutes. You write it down? Because I want to search for the human giant thing, and as we're doing it, it's boring. All right, guys, time is up. Let's do the question. All right, so what is the answer to f of 3? What's the answer to f of 3? Beautiful, it's 0. Obviously, because I don't integrate from anywhere, right? What's the answer to the derivative at 3? The derivative at 3, I will put it as the square root of 1 plus 3 to the power of 7. You see why? Because the derivative at 3, it's just you drop the x into the t here. You see that? What's g of 3? G of 3 is what? G of 3 is 0. Good. And g prime of 3 is the only one that's a bit annoying. G prime of 3 is what? So g prime of 3, let's look at it. So this is, okay, what is this? This can be written as f multiplied by 1 plus x to the power of 6 to the power of minus 1, yes? So the derivative is going to be f prime times 1 plus x to the power of 6 minus 1 plus f times whatever it is here. Why do I don't care? Because it's when I plug 3 here, it will be 0. So the answer here would be the derivative of f at 0. Let's just put it in. The derivative of f of g at 0, it will be f. It would be this expression. I copy it. So it's this expression 1 plus 3 to the power of 7 times parentheses 1 plus, or maybe I can just write it in division form. So it would be 1 plus 3 to the power of 6. Okay, because I plug in a 3 here. So submit your answers, and of course I'm always right. Good. You understand how I did it? It's product rule. Exactly, Alan, right? You see how I did it? It's product rule, and I didn't bother actually taking the derivative of 1 plus x to the 6 to the minus 1. Why? Because I knew I have to plug a 3 here. When I plug a 3 here, when I have f multiplying it, that would be 0 multiplying by the derivative of this expression. So I just plug it in and move on. Good? Let's move on. It wasn't as annoying as I thought it will be, yes, Alan, right? So
Yeah, we can easily agree on that.
okay, good. Christian, what part? What bothers you? Let's see. It was a product rule. Yes, it was a product rule. I just ignored. I ignored this term. F times with the derivative of 1 plus x to the 6 to the minus 1. I ignored it because look at it. I take the derivative at 3. So when I plug in 3 here, in the part of the product rule where I don't take the derivative of f, it will be 0. Do you understand? So I use that to shorten my work. That's what I wrote a star, right? So because I realized that whatever is the derivative of 1 plus x to the 6 to the power of minus 1, when I plug 3, it will be multiplied by 0. I hope you understand. Good. Now let's clear it and move on. Next question, guys. 46. Okay, let's do this one. You have 3 minutes to solve this. All right, let's do it. Okay. Let's do it, guys. Okay, so let's roll. So first of all, what's the antiderivative of x cubed? It is x to the 4 times 1/4, yes? Minus the antiderivative of 3 times f of x. It's going to be 3 times capital Fx plus 5x. So this is an antiderivative here, and I evaluate it from 6 to 9. So I write here 1/4, 9 to the power of 4 minus 3 times, what happens if I plug 9? I get 5. 3 times 5 minus 3 times 5 plus 5 times 9. So I get this expression minus the same expression at when I plug in 6. So that would be minus yes. Yes, so my 1/4, then we have 6 to the power of 4 minus 3 multiplied by minus 6. And then plus 5 times 6. Okay, this is what we should be getting. Let's see if we can input it this particular way. yes, you're right. You have to be careful, right? So here you multiply it by -3. So it's this 3 by -3. So I glitched here. Good. So you see, this is one of those annoying problems that it's kind of boring. So it's easy to do something there, right? So what should we put in? We should write parentheses. We have 1 over 4 over 4, 9 to the power of 4 minus 15 plus that's 5 times 9, right? So that's yes. So minus plus 45, right? And then I write minus and I open another parenthesis and I have 1 divided by 4, 6 to the power of 4 plus 9 minus 5 multiplied by 6. Good. Minus 5 multiplied by 6. So let's see if we get, well, it says that I made something, some mistake. Yeah, I see. That's why. I accidentally wrote the 6 to the 4 on the bottom. Let's correct it here. 6 to the power of 4. Okay, submit. Well, what does it put this? I don't know why it does it. I didn't do it, right?
Oh, Professor, it does it for both sides.
It does. Yes, you're right. So it's 6 to the power of 4. And here, and then, yeah, so you have to be careful, guys, right? So that's why when you submit work, I can look at it. So 6 to the, sorry, 9 to the power of 4. Whatever. So let's move on. Yeah, so whatever, right? So some sort of thing. You can simplify it, maybe 5 times 6. I'm not sure how this thing is reading it. Let's see what they do there. So they want to simplify it something like this, whatever. Show detailed solution, blah, blah. Okay, let's go to the next question. Here we go. So, yeah, maybe it needs a full number. I don't know, right? So I suppose when you have full numbers, calculate them maybe with a calculator or whatnot, right? I tried this different syntax. So we have here, the function is continuous and positive for x between 3 and 17, and the function is increasing. And then you have this information. All right, so if you don't know, I will explain it, I suppose, in a moment. They want to estimate what is f of a. What's the lowest value f of 8 can be, and what's the highest value f of 8 could be. Not exactly squeeze, but you'll see. So the function is increasing. Do you see what I'm saying? We know that it's continuous and positive, and it is increasing. So it means it's smallest at 3 and largest at 17. Well, it's you are right, James, but you have to be careful. What do you mean plug in where? There's no, we don't know the value of the function. You see, we only that it's increasing, and it's so. So let's do it together now. Okay, Rachel, let's see what we have there. Okay, so yes, so look, what's the idea? You can illustrate for yourself that here is 3, here is somewhere here is 8, somewhere here is 17. The curve is increasing. Good. So we have this region here and this region here. So we can get the integral from 3 to 8. The integral from 3 to 8 of f dx is what? It is the same thing as the integral from 3 to 17 of f dx minus the integral from 8 to 17 f dx, which is 185 minus 135, which is 50, correct? So it's 50. And so what do we have about this 50? So we see that from 3 to 8, the integral is 50. So that's the so what we hear from 3 to 8, the biggest value is 8, and the region here, look at it. So that would be how should we say that? So we have that 8 is biggest here and it is smallest here. Okay, biggest here and smallest here. So we know that that if we were to have a rectangle, so if it were all, so look at it, if 8 was the height everywhere, if at 8 we had this height everywhere, so we know that that this integral would be so. So we know that that 50 is less than or equal to the value f of 8 multiplied by the length of the interval from 3 to 8 by 5. Are you with me? Because you see the area under the curve from 3 to 8 is less than the value of f at 8 multiplied by the length of the interval by this rectangle. So that means that f of 8 is bigger than or equal to 10. Are you understanding what I'm saying, guys? So 10 is the value that I can place here. And what's the value I can place above? I just use this integral from 8 to 17. The integral from 8 to 17 is 135. So I know that that f of 8. Here, let me just erase this part. So clear. Now I know that that f of 8 multiplied by the length from 8 to 17, which is 9, right? So 8 to 17 is 9, is less than or equal to this integral from 8 to 17 f dx, which is 135. So the other value is 135 divided by 9.
Which is 15.
Which is 15, exactly. So you put here 15. Do you understand what I did? I just compared the area regions. And that's correct. Good. Do you understand how I solved it, guys? You see that I compared areas. You see the function is increasing. I just compared the rectangles to the actual area, which I do not know. Well, I just know the actual area here. You have any questions? Can I do you understand how I did this particular question, guys, or you're confused? So let me just again explain the idea. It's the idea is just that the words might kind of confuse you here, but here is the idea. So here is 3, here is 8, here is 17. The curve is increasing. Maybe strictly increasing, maybe not. Good. So what do I do here? I can estimate what value this is biggest because I have this rectangle. Look at it. You see this rectangle here? The area of this rectangle is 5 multiplied by, because this length is 5, so it's 5 multiplied by f of 8. And the area of this rectangle, it's 8 to 17 is 9, so it's 9 times f of 8. So I see that the green rectangle is smaller than the area under the curve. So basically, this area under the curve, it is from 8 to 17 of f dx. It's bigger than green. It's bigger than green. Good. And the area here from 3 to 8, it's bigger than red. It's sorry, it's this area is smaller than red. That's how I reasoned it out. Good. We'll do a few more examples and yes. Good. You follow me, guys? I suppose you do. I mean, what can I say if you don't? Okay, good. So that's the idea of this question. Let's move on. You have to be careful, guys. You have to do those exercises again on your own because you can easily get confused. Good. So let's go to the next question. Question number 44. Here is again, it's a similar problem. Look at it. How lucky you are. Okay, good, Christian. I wait 1 more minute and then we go through it, okay? Okay, Rachel, thank you. Okay, Alan, good. I think you got it. So, yeah, 1 more minute. Okay, it's time. Let's do it. So what's the idea here? Look at it. The function is again increasing. Be careful to read it. Increasing and continuous. So all I know is that the integral from 3 to 13 of f dx, that's going to be smaller because that 13 is the biggest height. So it's smaller than the rectangle, which is 13. Sorry, f of 13, which is f of 13 multiplied by the length of the interval by 10. And we know that this is equal to 90, which means that f of 13 is bigger than or equal to 90 divided by 10, or 9. So here I place 9. Now, on the other hand, I need the interval from 13 to 18. So what I can do is I can subtract from one from the other. So look at it. If I have 140 minus 90, that will give me the integral from 13 to 18 of f dx, right? And that will be an integral that's bigger than or equal to f of 13, because that's the smallest value, and 3 to 8 is 5 times 5, right? So yes, so the top value is 10. Good. You understood how I did it, guys? I just took 140 minus 90 and divided it by 5. Good. Let's move on to the next question. Now, okay, now it's decreasing. Here you go. Another one of that silly type. Go ahead, solve it. Okay, we have a few answers already. So let's do it now. You see, guys, you have to be trained to solve those questions more or less fast. Okay, so I see a lot of you say 16. So the function is decreasing. F is continuous and decreasing from 4 to 11, right? So f of 4, what's the minimum it can be? Simply 32 is the integral, and it's decreasing. So 32 is an area that would be less than or equal to the value of f of 4 multiplied by 2. Do you see that? Less than or equal, because the function is decreasing, so the biggest value is at f of 4 multiplied by the interval. So I compare to the rectangle. So that means that the answer is 16. Good. I see. You understand, guys, eh? Because I compare the area to one rectangle. Let's move on. Okay, here you go. So you find those questions simple, Christian. That's good if you do. Here is your next your next exercise. Suppose the function is continuous and the derivative is negative. Derivative is negative for all x. Okay. Select the appropriate comparison, assuming that a is smaller than b and smaller than c. The derivative is negative. What does it mean if the derivative is negative? Think about it. So the function is decreasing, yes. So spend, guys, so this, do it in 4 minutes from now. The options, look at it. The options are equal, greater, or less. Guys, 16 problems on the final. It means you want to move pretty fast. Okay, one person has the answer. I will explain in a moment, guys. Good. All right, let's begin, I suppose, right? Let's do this. You see, guys, you have to, when you train for this, you have to think relatively fast for this exam. So first of all, what does it mean that the derivative is negative? Remember what derivative is doing to us, right? So the derivative, negative means that the slopes are inclined this way. So that means the function is decreasing. Do you understand that? If the slopes are inclined this way, derivatives are just, you are talking about, you see, this is how I imagine the functions built up in calculus. They are segments of lines, like tiles. And what you can do to create a curve, you can tilt those tiles. They're always connected, but they can be tilted. So here derivative is negative, positive, negative, positive, negative, positive, maybe negative, right? So if the derivative is always negative, that means the tiles are always tilted down. You understand how I visualize it, guys? Yes? So is it clear, right? So it's just line segments. So if the derivative is negative, the lines are all tilted down, which means the function is decreasing. Please confirm that you understand that the function is decreasing. because I don't know what you know, guys. Most of you, I have never seen your faces. Roger, good. So that means what? That means what? Look at it. So the integral, but the function is positive. So here from a to b, and here I integrate from a to c. Even though the function is decreasing, it's always positive. I'm still accumulating more area. So the first thing is that the left is bigger than the right. Do you agree? That's because I'm just still accumulating area, because the function I'm integrating is positive. Now, what about this situation? From A to B, and then I move the intervals 3 units to the right. What's the situation? Would anybody write, please? What's the situation here for the second integral? Come on, it's one symbol. Doesn't greater than, exactly, because the function is decreasing, so that would also be greater than. Right? You're just integrating over shorter curves. Now, what about this situation? AB, f of a times b minus a. That's what is the situation now? Less than, because f of a is the biggest value over the interval. So now this is less than. Submit the answer, and oh, I forgot to do it here for some reason. F of b, I forgot this one. And what is this? AB, f of b, b minus a. So that's of course that value is the smallest, right? So it should be like this, correct? Let's submit it. What did it want here? A to B, A to C. That's nonsense. This is bigger. What do they want here? From A to B. Right. C is not in between. That's right. That's my mistake. C was not in between. C was the, of course. So it's like this. Yes, makes sense. I thought C was in between, but it's not in between. You have to be careful. Good. Makes sense, guys. I see. Why is the right bigger than the left? Because C is, look at it, C is bigger than B, so I'm integrating more area. I just assumed that C is between A and B accidentally. Do you understand what was the mistake? Good, wonderful. Next question is 41. Go ahead. F is continuous and positive, and now the derivative is positive. What's the relationship between those curves, those integrals? What are the possibilities here? Okay. Okay. So you're saying the first, you're thinking it's equal. All right, wait one more minute. Remember your answer. I'm going to ask it again. Okay. Okay, guys, 1 more minute and I'm answering it. Not all of you are still having the solution, so it worries me. Okay. Gooding, okay. Okay, Nassim, good. Good, good, James. Wonderful. All right, time to answer the question. So the f prime is positive, right? So here it's positive. Look at it. So what does it mean about the curve? If the derivative is positive, it means that line segments are building upwards, right? So here is the point 1, and here is the point 2. So the curve is something like this. It's increasing. I don't know if it's exactly like this, but it's increasing. Okay. So now look at it. First situation is we have two areas. We compare two areas against one area from 0 to 2. You agree? Which means what? Which means that twice this area is going to be smaller than this area plus a bigger area. So the answer to the first part is that the left side is bigger than the right side. And now from 0 to 2, the interval is from 0 to 2 as opposed to from 2 to 4. So clearly from 2 to 4 is bigger because the function is increasing. So that would be like this. Good? Do you understand? So it is bigger and then less than. Do you see why? Because this is twice the small area, but twice the small area is less than the small area plus the large area, right? And this is just comparing over the interval from 0 to 2 to the interval from 2 to 4. Do you understand how I use the fact that the derivative is positive? Derivative positive means that the line segments are oriented this way, that build up the curve, right? The curve is built up of small line segments. If they're oriented this way, the curve is increasing. You follow me, guys? Next question.
Wait. I got a question.
Yeah.
So for the question 20 41, right?
Mm-hmm.
For the second question,
Yeah,
why couldn't it be why couldn't it still be, because I know that you just did the graph, right? So
yes.
I know that you're combining the two because is two minus 2, well, not combined, it's 2 minus 0, right? But the other one's 4 minus 2, right? Isn't it technically, no, never mind, you're right.
it's just the region, the curve is much higher between 2 and 4 than it is between 0 and 2, and the width is the same.
Okay.
So the skyline, the area for the second part is bigger. And you
Okay.
understand why the first integral is so, because the integral from 0 to 1 multiplied by 2, it's just like adding two small areas. Whereas this integral is adding one small area like here and plus another bigger area. So that's why it's bigger. Okay, so then let's do question number 40. So let's see. The function is continuous and the derivative is negative. Makes sense, you follow. You see, it says add work. If you want to, you can add work. But if it's correct for this type of questions, I'll just mark. I'll give you the full credit. You understand? For this question, if you mark it all correct, I'll probably give you full credit without the work. But always have work ready in case you want to submit it. Okay? Definitely for questions where it's obvious that you had to do work, I would not believe you if you don't submit it. Okay, so a function is positive and the derivative is negative. Function is positive, derivative is negative. So what happens here? From A to B, we're using left hand rule. That's the left rectangle approximation, and Rn is the right rectangle approximation. And this means I had 500 rectangles that I constructed. So you have to say less than, equal, or whatnot, right? So fill in those blanks, please. You have 2 minutes. Very good. Okay, 1 more minute. It's a simple question, guys. You just visualize the graph and the rectangles and you compare them. All right, time. So the function is decreasing. Do you agree? The function is decreasing, which means that the curve is going downwards. So that means that if I use the right-hand approximation, I'm getting smaller bounds for the area. So the answer is area is bigger than 500 rectangles. Now, because the left-hand rectangles are actually, I'm taking the maximum value for the rectangle, the left sum is bigger than the area. Now, if I compare right to left rectangles, naturally left rectangles are bigger. If I compare left 100 to left 500, because the rectangle is spanning bigger regions, this area is bigger. With fewer rectangles, I get bigger area. Good? Do I need to explain more? Okay, no messages means I don't need to explain more. I move on. You understand how I did it, guys? It's very simple. I built the thin skyscrapers underneath the curve, and the curve is decreasing. So I know right-hand approximation is the smallest possible approximation. Okay.
Wait. I'm sorry. I have a problem with the last one. Why is the last one is L to 100 is greater than is great? Because you're saying it's more area,
Okay,
right? But
sure. That means I have to draw it. Thank you for letting me know. So I need to draw it, right? So that's what I asked you guys. Don't delay with responses. Okay, so we have a decreasing curve. Yes? Let's not do 500 rectangles. Let's do 2 rectangles and 4 rectangles. Okay? So let's see what happens with, let's say, last one. I'm using left approximation. Okay? So left approximation by 2 rectangles. What do I get? I get, here is my first rectangle. That's first rectangle. And here is my second rectangle. You see that the 2 rectangles are bigger than the area. Yes? Now let's do it with 4 rectangles. What should happen? If I do it with 4 rectangles, I partition here and here as well. So what I have is, it would be this region plus this region. Do you see what happened here? They still match the bigger rectangle, but the combined area got smaller. Now it's here, and so it's this rectangle and a smaller rectangle. So the areas, the left areas get smaller. They are decreasing areas, right? So the more rectangles I have, the smaller they get. The right rectangles will be increasing in area. Below A. So the right rectangles will increase their area until they match A, and the left rectangles will be decreasing their area until they match A. So they will converge. Good. Next question is 39. Am I right? 39, or did I miss something? Yes, 39. Good. 39. Integral from 5 to 15 is 10. From 15 to 5, we need to find. Okay. From 15 to 5 is what, guys? It's the question takes you, I'm giving you 1 minute. Okay, good. 3 people see it right away. Okay. Any more? Okay. Your minute is not over. Come on, you can do it. Okay, your minute is over. Now look at it, 5 and 15, 15 and 5. They're always negatives of each other. So the answer is minus 10. Good. I hope you understood why the answer is minus 10. If you're taking Calc 2, you're not properly prepared. I'll mention that later. All right, here is another equation. From 2 to 11, 3 f of x. 2 to 11, f of x is 16. 2 to 11 of 3 f of x is what? Yeah, very easy, right? All right, so this, I'm not gonna waste time. It's 3 times 16, so the answer is 48. By the way, we do want to experiment. What happens if I say 3 multiplied by 16? Would that work? Yeah, right? So you see, just checking what sort of things you can submit and that it still works. Good. So 37. Okay, the integral from 1 to 7 is 19, and from 2 to 7 is 9. From 1 to 2 is what? 1 minute. Less than 1 minute, honestly, right? 30 seconds. Not even, right? It should be immediate, right? 10, 10, 10, okay. It's enough time. Look at it. 19 minus 10, it will give you the area from 1 to 7 minus the area from 2 to 7 is the area from 1 to 2. So it's 10. By the way, let's see if I write 19 minus 9. Will it work? Yes, it does, right? So you can just check. You don't need to do much. Don't do extra work if you don't have to. 36. Quickly, guys. So that's the same thing, right? So simply 6 plus 7. You don't even need to do anything. Yes? You can be lazy completely. I don't have to do anything here. The final is going to be similar to those questions. I'm too sad that you're too happy about it, right? Because I do not know. I imagine it will be those questions and you will be copying my results that I gave you into this. Right. Well, I mean, this is only 14 questions. Maybe there'll be hard questions, right? We're just doing integration, right? So here is the next question, 35. Don't be too happy. Maybe some are tricky. Y f of x is shown below. The integral from 0 to 4 is what? You have to figure out this area. Or you don't even, I bet you don't even have to do that. Okay. I'm gonna give you 2 minutes. That's actually too much time, but whatever. 9. And I'll try to input the numbers in the laziest way possible, okay? So to see if that works. Come on, guys, fast. We need to cover so much more material. All right, I see. So I'm actually not going to give you the time. It's too much, right? So the integral from 0 to 4 is just the integral of this triangle. The triangle is 4 by 4 multiplied by 1/2, right? So the answer is, let's just do this. 1 over 2, 4 multiplied by 4. I'm just checking if it works when you don't bother, right? Now the integral from 0 to 9 is the same thing. 1 over 2. 4 times 4. That's this area from 0 to 4, and then minus this area from so let's see. So the area is going to be. I'll just do it like this. Plus this rectangle is 8. This triangle is 8 by minus 4. So that would be 1 over 2. 8 multiplied by minus 4. That's from 4 to 8. And then minus 4 multiplied by 1. So just simply minus 4. Let's see if that's accepting my answer. I didn't accept this answer. Yes, 4 times minus 4, you're right. So that should be, from here it's, you're right, 4 to 4, right? So I made a mistake here, right? So now submit. It accepts it, okay? So I accidentally said it 8. Thank you for correcting me. It's from 4 to 8. This distance is, you can also write 8 minus 4. I think this thing will accept it. Good? You understand the idea? So now I'm moving to question 34. Okay. An object moving in straight line with initial velocity minus 20 meters per second undergoes an acceleration of this thing seconds after an experiment begins. The velocity of the object after t seconds is what? So go ahead, guys. You have, for this problem, you have 4 minutes. 1 more minute. Okay, good for the velocity, but don't forget about the position. All right, are we ready? Yes, we should be ready. So for the velocity, velocity is the antiderivative of acceleration. And at zero, at the accelerate, so the velocity at zero is minus 20 meters per second, yes? So be careful. So it's this, guys. So it is, the antiderivative of 60 is 3t squared minus 10t, good, minus 20, good. I hope it's correct notation. I don't know if it's syntax set. Okay, so what about the position? So I need to integrate it one more time. So that would be t cubed minus 5t squared minus 20t. Good. Let's see if that works. Yes, it was correct. Good. Do you understand how I solved it, guys? Let me quickly know if you need any explanation for this problem. 1, 2, 3.
Can you explain it?
Can I explain it? Okay, so do you see what is acceleration? Acceleration is change in velocity divided by change in time. Yes?
Okay.
Change of velocity over change in time. So that means that acceleration is the derivative of velocity. Yes? So here we have the acceleration. So we take the antiderivative of acceleration. It is 3t squared minus 10t. And if I plug t equal to 0, it must be minus 20 meters per second. So my velocity is 3t squared minus 10t minus 20. Because if I plug 0, it must give me minus 20. Remember that I can obtain velocity up to a constant addition to the antiderivative. Right? All antiderivatives of this function are just plus a constant. That's it. Good? You with me? So, and then for the position, I take another antiderivative, and then after the initial motion, the distance, so I know when I plug in 0, it should be 0 for the position. Okay, if you want more elaborate explanation, let's wait until after this review is over, just because I want to cover more questions, right? I hope you understand, guys. All right, here is another example, question number 23. At noon, ship A is 10 nautical miles due west of ship B. Ship A is sailing west at 20 knots and ship B is sailing north at 24 knots. How fast in knots is the distance between the ships changing at 3 p.m.? So you have, for this question, you have 4 minutes. Draw yourself a picture and figure what's happening here. Can you hear me? Yes, I'm not sure if everyone is mute. Not everyone is mute, I'm assuming. Christian, you had a question? I'm sorry, I'm not that fast of a reader. Okay. One more minute and we solve it together, okay? All right, let's do this together. So that's related rates. It's always very tricky to solve those questions, but you have to picture out what truly happens here. I hope you watched the lecture notes on the related rates. So we draw ourselves a coordinate axis. So this is north, this is west, okay? So what happens is that if you play this video, you are gonna see two ships, right? So what you have is, here is one ship, and its position is at time t, it's always sailing west, it's x of t. And there is another ship, and that is y of t. So if you play this, the ship is moving in this direction, and this ship is moving in that direction. Yes? So now, what is truly happening here, the distance between them is this line. That's the distance between them. So let's call the distance E. E for Entfernung, which is, I don't want to call it D because it's distance in German, because D might refer to the derivative. So what do I observe? I observe this relationship. So I observe that E squared is equal to x squared plus y squared, where those are really functions of time. So the derivative is 2e dE dt equal to 2x dx dt plus 2y dy dt. If you don't understand related rates, again, I have the lecture notes on that on my website with detailed solution to some of the problems. So I clearly do not need the 2's. So I can cross those two out. And I know that at 3 p.m., so noon is 12, right? So or 0, 0. So it's really what? So 12 is, so 3 p.m. It's really 3 multiplied by, so each of them is moving what? So X is moving 20 knots. So we have 3 times 20 knots is how far X is equal, is how far X traveled. Dx dt is times 20. And plus what is y? Y is 3, because it's moving, I think, ship A. No, ship B. I have to be careful here. Okay, so so X is the position of the horizontal ship after 3 hours, because we're interested in where is it? We're interested at 3 p.m. So X at 3 is equal to 3 hours multiplied by the speed with which X is moving due west. So it's X is it's times 20, right? So X is 3 times 20, and dx dt is 20. So we have y at 3 is the speed of y. So ship B is sailing north at 24 knots. So it's so it's 24 times 3, and dy dt is 24. Yes, of course I need to include the 10 because that's the initial. Yes, you're absolutely right, Rachel. Right. So X is 70 because initially X is 10, and Y is at 0 and X is at 10. So actually I need to the X, I need, thank you for noticing, I need to add the 10. Okay, because initially this boat is at 10 units away from the Rogers, so it's actually going to be 70. So and then 1 second. All right. You still with me, guys? So this is the xdt is 20, and so you just plug in those values here. You just need to calculate E. What is E? At this distance, E is going to be it's going to be 70 squared. So E is 70 squared plus the corresponding value for Y, which is 24 multiplied by 3 squared. You take the square root. Okay, that's E. So simply what we have is that dE dt would be God damn it, I'm so annoying to put it in. Yeah, so it would be basically X multiplied by dx dt plus Y by dy dt divided by this expression. So I guess I don't know, I should write it on a different here on the whiteboard. So the E dt should be simply X multiplied by dx dt plus Y multiplied by dy dt divided by root of X squared plus Y squared. Okay, which at the particular values that I have here. Okay, take care, Alan. Okay, so which if I plug in the right X and Y, So x we said is so we have x times dx dt. Let's see if we can just don't have to evaluate anything. So x times dx dt is 70 multiplied by, I believe, by 20, yes? And plus, what's y? Y, it's 3 times 24 multiplied by 24. Okay, divided by root of 70 squared plus 3 times 24 squared. Let's see if I can actually put my answer this way without carrying any calculation. Okay, let's see. So what I have is 70 times 20 plus 3 multiplied by 24 multiplied by 24 divided by root 70 squared plus 3 times 24 squared. Let's see if this answer is acceptable. Yes, it is acceptable. Good. You see, so you don't need to carry out all those annoying calculations. Now, if by some chance, guys, I hope you know where you can read about related rates. It's a very difficult topic. It's the one of the more difficult topics in calculus, right? So let me show you where you find it. Again, calculus, derivatives, no, chain rule implicit differentiation, related rates. You see, look how I wrote you 12 pages. It's very simple, right? You read those 12 pages, or we can go over them together. You can solve those examples. You have a chance to know related rates. Anyhow, moving on. Question 32. A spherical snowball is melting in such a way that its radius is decreasing at a rate of 0.1 centimeters per minute. At what rate is the volume of the snowball decreasing when the radius is 17 centimeters? Okay. What's the volume of, so we have a spherical snowball is melting in such a way that its radius is decreasing. And we want to compare volume. So we need the relationship between the volume of the sphere and the radius. You have 4 minutes. To whiteboard. Ping, ping, sorry, I didn't see your message. Here's the whiteboard. Good. Okay, so some person already has an answer. We'll see what it, you see, you can put the answer in a formula. You don't need to solve anything. Okay, you don't need to solve anything. We put an answer as a formula. Okay, I think we are, I'm waiting 1 more minute and we solve it together. All right, time. Let's do it together, guys. So first, we need to know the relationship between radius and a sphere. So if this is a sphere with radius r, then the volume is 4 over 3 pi r cubed. You follow? So if this is a sphere, it's 4 r cubed. And then we are told by this problem, what are we told? The spherical snowball is melting in such a way that its radius is decreasing at a rate of 0.1 centimeters per minute. So the radius is decreasing constantly. At what rate is the volume of the snowball decreasing when the radius is 17 centimeters? Okay, so the radius is, we know that dr dt is always, what did I say, 2 centimeters, right? I'm not mistaken. No, 0.1 centimeter. 0.1 centimeter per minute. Okay, so that means that if I take the derivative, so this is my volume. If I take the derivative of the volume, so I can say dv dt is what I want to find out. It is equal to 4 pi r squared dr dt, right? And I'm told that that I want it when radius is 17, right? The radius is 17. So what does it mean? It means that my plug here is r equal to 17. So it's 4 pi 17 squared multiplied by 0.1. Okay, that's the number that I will try to put in. Let's see if that works. So I write 4 multiplied by pi multiplied by 17 squared, and then multiplied by 0.1. Okay, and I did it right. Make sense? Do you understand this problem, guys, or I'm just talking to my nose? Did you read my notes on related rates? All right, let's look at question 31. Okay, Alexa, take care then. Question number 31. You mean from this list, yes? Or from, you mean Christian, I'm sorry. You mean from that list of questions you want to ask me, or from some
Is the
other?
final going to only contain what's on this list? Or is it going
My
to be...
understanding is that that what can it truly be is that you see you have this list of 15 questions, and this list contains the possible final questions, and they might be very, very similar with different values. So it's the best strategy, I think, based on what I know, is to make sure to go over all those problems and know them. But of course, it might contain other questions. I do not know how the final looks like. But I'll try to answer your questions if you have the energy for them. Okay, so we'll see. Okay, thank you, Rachel. So you have to figure out how rapidly the object is moving 8 seconds after the experiment begins.
I lost connection again.
Oh, sorry.
Because I have this question, it's an evaluate a limit function.
Yeah, after this one, I'll do your question. What do you say?
Okay.
But guys, your strategy is this. You see, you have those 50 questions. Make sure you know every single question here, and you know how to solve it, and it's going to be familiar to you. I cannot promise those are the questions on the exam, but I think highly likely that most of the questions will be similar to what you have in the practice. All right, I think it's time to solve this particular question. Yes, guys, 31, let's solve this. Suppose the height of an object is given by h of t, which is this thing. How rapidly is the object moving 8 seconds after the experiment begins? What do you have to do to this thing? You just differentiate it, yes? So what you do is you take the derivative and plug in 8. So the answer is simply minus 20 multiplied by 8 minus 5. Good. Let's see if that works. Score on last try 0.5 of 1 point. Why is that? Why didn't give me a full credit? I don't know. I have to pick the units. Ah, right, right. I see. 3 seconds after an experiment is given by meters. So so how rapidly meters per second. Okay. Okay, now I see. Thank you guys for, you see, you are very observant. I hope you'll be that observant on the exam. Good. Meters per second. Good. So good. You need to put these units, and this question now is correct.
Will we be given multiple tries?
I do not know. Maybe not that many. Maybe, but be careful, right? So maybe for each segment you can get a try. Like I had a try for here and a try for here, right? So that it's 2-part question, right? But it's not only the system that's grading you. I will be looking at how you solve the question. Oh, you have to go, guys, but maybe you know, before you go, I should try to find that thing that I was trying to show you, right? Could you wait? So I'm gonna pause the recording, and all right, Christian, tell me what would you like me to explain?
Okay, so I found one of these questions on your PDFs for the finals.
Okay.
Like, it says evaluate the limit function of x going to 0 and the function is 1 minus cosine x over x.
Or like this?
I just wanted a review of how to
Like this, right?
evaluate limits. Yeah. Yes,
Like
yes.
this. Okay, so what does it look like? We'll look at this limit. It looks like what? It looks like somebody is doing a what? Well, you can put a minus outside, and you have a limit as x goes to 0, and you have here cosine x minus 1 over x. So this looks like somebody is doing what? So you have a cloud, and that cloud is saying, somebody is trying to find a, taking the derivative of what and where? Well, Christian, you say taking the derivative. One morning, Christian, you're saying taking the derivative. Taking the derivative at what point?
Isn't it to the cosine of x minus 1 or taking it to 0?
Well, I mean, you're just reading what the limit is saying, but what is somebody truly trying to do here? They're trying to find the derivative of what function at what point? That should be, guys, by now it should be immediate. At point 0 of what function? Cosine, exactly. So that's the derivative of cosine. So what is this? Look at it. This is limit. You can, if you prefer, switch to h. Limit as h goes to 0, cosine of 0 plus h minus cosine of 0, because 1 is cosine of 0, divided by h, right? It's the derivative of cosine, which is where x is 0. So that's minus sine of 0. And that's equal to 0. So the limit is 0. Do you see? Of course, we need, this limit is not easy. I mean, you need to know this limit before you can possibly, and there is a minus in front of it. I forgot to multiply by minus, but it doesn't matter. It's minus 0, which is 0. Right? We need to know this limit ahead of time if we want to know what's the derivative of cosine. But you can use, if it's an exam or whatnot, you can recognize this as the definition attempt to take the attempt to take the derivative by definition of cosine. You all see that, guys? I mean, guys, do you see that? I don't know. I mean, I want to believe you. I really do. Yet you see this. It's just definition of derivative. Now, you need to know this limit. Do you understand what I mean? I mean, I do not know that the derivative of cosine is minus sine without knowing this limit beforehand. So I use squeeze theorem to prove it. So in some sense, I'm cheating here, Christian. Do you see what I'm saying, right? So I would not know that the derivative of cosine is minus sine without knowing the derivative ahead of time, beforehand, right? So I have to actually figure out a different way to find this derivative when I first established the derivative of cosine is minus sine.
So if I'm looking at this correctly, right? Cosine x minus 1 over x is just cosine?
Cosine x minus 1 over x. What do you mean? It is. What do you mean? It's just cosine? No, it's. What do you mean?
Or it's just taking the cosine x and trying to find the derivative of that. Only.
It's just the derivative. This is the derivative of cosine at 0. That's how it. That's the definition of derivative of cosine at 0. All right. So let's do next. We do next question from the review. And then if Christian, you have other questions you want to throw at me, right? We will do that or anybody else, okay? Because I think the review is what you immediately have to work through. Good? By the way, how many of you are taking Calc 2? If you're taking Calc 2, then we're not done with you, right? We're gonna continue preparing during the winter break because you are not ready. Well, maybe you are, but I mean, I want you to be truly ready. Yes, I cannot let you out alone into the world without getting you ready for Calc 2. You must be the best student since you were my student. You don't look happy, Rachel. Besides, I think you are taking probability theory next semester. I have this feeling. Okay, so you drop everything, you just sit in my probability class. So that's a real good class. Interesting. Question 30. Okay, a circle's radius is increasing at 0.3 feet per minute. How rapidly is its area increasing when the radius is 3 feet? Go ahead, you have 4 minutes. No, just at Hunter. But how do I teach probability? My God, you should have seen how I failed so many people there, right? It's the exams are so difficult, right? So, and the funny thing, I expect them to be very happy. You should see, right? I'm gonna train you. I'm gonna lure you in, and that's it, right? And you will train with me. Yes, but having to take a class does not mean having to learn it, right? Having to learn it means you sit with me and you learn it. Yeah, what does it matter? You take this class. Do I believe that most of you will pass? Do you know? Do I believe that most of you learned anything? No, I do not. Okay, well, it's time. Yes, guys, let's solve this question. Are we ready? So we have a circle of radius, whatever, increasing. How rapidly is the area increasing? Okay. Here is the circle. And we're oh my God, people are leaving me. 15 people left. My God, 0.3 feet per minute is the rate at which the radius is increasing, right? So here is that radius. So we have the r dt is, I forget immediately. It's what? It was 0.3 and we wanted 3, okay? The RDT is 0.3 feet per minute. Good. And now what? And now we have the area. It's equal to pi r squared. So we want to know how rapidly is the area changing. All right, Christian, I'll answer your question. We'll do one question. Again, I like your question, Christian, so don't, right. I personally don't care about this final. I mean, but does it matter, right? So dr dt is 0.3 feet per minute, and we want to know dA dt, where radius is, I believe, 3 feet. Okay, so what do I do here? I simply have dA dt equal to 2 pi r dr dt. Now, when r is equal to 3, I simply have 2 pi times 3 multiplied by 0.3. That's my solution, right? So let's see if it's right. So it would be 2 multiplied by pi multiplied by 3 multiplied by 0.3. Ping Ping, you are writing on my good job, huh? Thank you for your how do you say, for your approval. Good, let's move on. So question 29. Let's do what, a few more questions, and then if you decide, I mean, I see I'm losing already people. Guys, before I continue, by the way, would you want to come tomorrow to continue the review, to continue Monday, or you had enough of me? Yes, please, you will come, right? So if I schedule a review tomorrow at 1, you would really want, yes, physics final, it's a bit more interesting, Christian, but is it really a physics final if it's not the book I suggested on my website? All right. So, okay, so I will email people. I probably will come tomorrow again so that we continue. Depends on timing, 1 to 3, I assume. Yes, you see why 1 to 3? Because you understand, I spoil the fun for my probability students. I told them we are going to have Christmas together, right? Because we have to cover so many other ideas, right? Somebody somebody asked me, how long have I been studying statistics? Because am I a statistics professor? All right, so let's solve this problem. Oh. All right, so guys, here we go. Let's solve this question. Maybe answer a few of Christians afterwards, and then call it a day. I still have to grade your exams and whatnot. I finished halfway through. All right, so we have this horrible question. So suppose the only critical values of f prime are 10, 20, 30, f prime, and f double prime have the following values. Based on this information, at x equal to 10, at x equal to 20, at x equal to 30. Let's see what we can select. And in guarantee, you can see local maximum, local minimum, nothing. Same thing here. Same thing here. Right? Okay. All right, let's do it. What do you say? So let's, do you understand this idea? So what do we see here? So at x equal to 10, let's see, we go from at 5, the derivative is minus 3. And then at 10, it's 0. And at 15, it is 3. Okay, so what are we guaranteed? So you see, we know that at 5, the derivative is negative. At 10, it's 0. At 15 is 3. What are we guaranteed? Well, actually, it could change so many times between minus 3 and 3. So we are guaranteed nothing. Yes? We're guaranteed nothing at 0 because we do not, I mean, actually, let's see, be careful here. Maybe I misread the question. The derivatives, the only critical values are we have to actually, this question is actually very, okay, second derivative exists. It means first derivative is continuous. First derivative is the function is continuous. So actually careful. So this is a tricky question. So at minus 3, this is the only 0. And then we have 3. We can, what can happen? Let's just quickly look at it. Okay, guys, what can happen at this 10? So the derivative, we are decreasing, but maybe we're decreasing. We don't have, the derivative never has any other intersects. So the derivative at 10, here it's negative. It cannot become positive without crossing the x-axis. So at 5, it's minus 3. It has to stay negative. It cannot become positive without crossing the x-axis. Here it's 0. And it does become positive after 0. So actually, I was wrong when I said guaranteed nothing. We are guaranteed that this must be, look at it, negative means the curves are falling for f, and then they are flat, and then they grow up, which means we have a local minimum. Do you see that? Local minimum. I said guaranteed nothing, but that's only because I did not read this condition. Es ist eine sehr tückische Frage. It's a very tricky, very sinister question. So what do I put here? I don't put nothing. I put local minimum. Yes? Okay, good. I'm glad if you understand it so fast, faster than me. Next question is at 20. You are guaranteed what? 20, look at it. 15, it's 3, then it's 0, then it's negative, right? So it must be positive, 0, then negative derivative. Look at it. What are we guaranteed? We're guaranteed a local maximum. Do you agree? Because at 20, it's 3, derivative is increasing and onwards, right? So at x equal to 30, you guarantee at 30, minus 2, 0 to 8, right? Minus 2, 30 is, that's the first derivative. Minus 2, then 0, then 8. So negative, then 0, then positive derivative. So it's another local minimum. Yes, that's what I'm going to say. Let's see if I'm right. I put minimum for 20. 20 positive 0, so it should be a maximum here. Thank you for noticing, right? Middle is maximum, positive 0, negative. You understand how I build it up, guys? I'm claiming this. I'm claiming derivative is positive, 0, negative. So the line segments, they form a U shape of sorts, right? How they are arranged. You all understand me, yes, guys? So now the moment of suspense. And of course, I'm correct. How could it be otherwise? Right? Good. You want one more problem like this, or you want to go? Christian had some interesting questions that we should solve. So guys, if you're taking Calc 2, you know, here is what I was told about Calc 2. I was told that a failure rate in Calc 2 is 50%. 50%. Do you understand what I'm saying? Yes. I will work with you a little bit to make you ready for Calc 2. If you are taking it, right? But really what we want to do is we want to get ready for probability, which you are taking with me next semester. All right, so you want to do one more question, or you want to now go to something else? Quickly answer. More of those questions or less of those questions? My God, come on, guys, you can decide. Okay, Nassim wants more. Hey, what about the rest of you? You don't know if you want more or less? Okay, let's do a few more, maybe 2 more questions, and then I'll answer Christian's questions, okay? And you can stay think about those as well. Question number 28. Here is this question, okay? Okay, so this is the graph of the derivative. Based on this graph, what you have to do is you have to find what's the relative maximum is at what position. That's the derivative graph. And the relative minimum, where is it? Or maybe there is no relative minimum. That's the graph of the derivative. Do you understand? Not of the function. This is the graph of the derivative. Do you understand? Not of the function. Be careful. All right. It's time, I think. Let's look at this question. Look at it, guys. This is the derivative. All I pay attention is not the peaks and valleys of it, but whether the curve is negative or positive. You see at around -3? At around -3, the derivative goes from negative to positive, which means that -3 is a local minimum. Local minimum is at -3. Do you see how I see that? Derivative at -3 is negative. Let me again annotate it. Look at it. Derivative around -3 is negative, which means that the curves, and notice it's a straight line, so it's parabolic like this. And then after -3, which is over here, it becomes positive. So that corresponds to a local minimum at -3. You see this? Yes? Now, what about the local maximum? Is there a relative maximum? Look at it. Here we're decreasing. Here we start again increasing. We continue increasing at this point. It means that second derivative doesn't exist, but we continue increasing. Here we increase slightly slower. Here we stop increasing. Look at it. So it's still positive, you understand? And continue increasing. So all of those are positive increases. So there is no relative maximum, I'm going to say. Do you follow what I'm doing, guys? You see, you might have been misled by the peaks of this graph, but it doesn't matter. Or if it's the derivative, all I pay attention to is whether it's above the x-axis or below the x-axis. And of course, I'm correct. How could it be otherwise? Good. So let's now move to the last question for today, and we can continue tomorrow with those types of questions from 1 to 3.
Should I save my questions for tomorrow?
If you have energy, I will answer them today. If you have energy, right? I have a lot of stamina, right? So I'll answer your questions today if you want. I just finished this question and then we'll talk about yours.
Okay, no worries.
But for sure, Christian, don't lose sleep. That's a very silly thing to do, right? To not sleep. I sleep even if tomorrow is my execution. Okay, so derivative is shown. We need to know, do we have a relative maximum? Okay, so are you ready? I think we should be ready. Is there a relative maximum? Well, look at it. We are positive before we reach -2 and negative afterwards. So at -2, we expect a maximum, yes? And what about relative minimum? We see that at 2, the derivative goes from negative to positive, right? So that means at 2, we have a relative maximum, yes? By the way, have you watched my lectures? No, you haven't, right? The videos on maximum, minimum, or anything else I have, right? Related rates? No? No? Yes? No? Yes, Christian. You did? Good. All right. So now, what's the next question? Just a second. Let me see what's the next one. Is it the same type? Okay, that's a different type. So we talk about those questions tomorrow. What we do now is go to Christian questions. Go ahead, Christian. What do you want to ask me? Christian, I don't hear you. I think you're on mute.
I'm on mute this entire time.
Oh, yeah.
Find the area under the graph of y equals 1 over x in between x intervals e to the power of 3.
Okay, so that's just the integral from e to e cubed of 1 over x dx, yes? And what do you get for it?
Oh, I was thinking more like, since it gives me the y value, I would have to find the derivative of y?
No, it's much simpler problem. What the y value? Find the area underneath the curve. So here is y equals x, y equals 1 over x. It's this curve. And then here is the point e, and here is the point e cubed. So you're asked, this is just the skyline. I call it the skyline.
Oh, because I thought, I mean, if it told me y prime equals 1 over x, I would probably have to do the antiderivative.
Yeah. Well, sorry, y prime. Then you have to do that. Well, again, no, you do have. This is the function. This is the function that is the skyline, and you find the area. So
Okay.
it ends up happening that by the fundamental theorem of calculus, the area is simply the antiderivative of this function, which is ln x, evaluated from e to e cubed, right?
All right.
Which is simply
Simple.
3 minus 1, which is 2.
Simple. Thank you.
Yes, it happens if you don't lose sleep.
No, I just thought it differently.
Okay.
And there's another evaluate limit function. So it says evaluate limit of x going to positive infinity. And the function is x parentheses square root of inside the square root is x to the power of 2 plus 4. And then outside the parentheses is minus x, and then you close the parentheses.
Like this.
No. First it's minus x, and then.
Okay. So 1 second. Okay. So like this, yes.
Yes.
Okay. So we have. So what you do is so it's the limit, right? It's the limit. Sorry, not integration. It's limit as x goes to infinity. Good. So what do I do here? I say this is limit as x goes to infinity. By the way, do you want me to wait? Do you want to solve it, guys, or what? Like, I'm pushing it, but what about you? All right. Anybody needs to see the imprisoned cat or not? Yes, there it is.
Yeah. Oh shit. No.
All right, are we ready? Positive infinity. Let's see what happens here, guys. Okay, let's be careful here. So I have this, I can factor out this x. So we have here x. I can write it as x squared, root of 1 plus 4 over x squared minus 1. You follow what I did? I factored out the x is positive, so I factor the x from the parentheses, and I factor it from here. I get x squared times root of 1 plus 4 over x squared minus 1. Are you with me? No?
How did you get 1 from taking out an x?
Okay, then no, here, let's do it slowly, right? So in this parenthesis, what do I have? I can write here this as x squared 1 plus 4 over x squared. And I push this x squared out, which becomes x. And I factor it out. So I have x times x squared, it's x squared. Look at it. This is x squared times this. Do you see it now? Yes? No? God, you know, guys, what it's called? It's called algebra, which you should practice doing. My God, right? Algebra. That's how I get it. Does it help?
Oh, yeah, because the x squared is in a square root. Okay, I got
Yes, because x squared is in a square root. Okay, guys, let me be sure. It's taking out the x. Yes, so you take the x, you see, from here, and I push it out. Are you all with me, guys? Right? I only have what 12 of you. Are you here? I push out x, and now what do I have here? And now I do the following. I say this is limit as x goes to infinity, root 1 plus 4 over x squared minus 1 divided by 1 over x squared. And this requires a 4, because then it is, look at it. I see and I look at this expression, and I think I want a 4 here. And if I want a 4 here, I need to multiply by 4 here. So the result is 4 multiplied by the derivative of root x, where x is 1, because that's the definitional derivative. Yes? You're laughing, Christian. It's the definitional derivative, which is what? What's the derivative of root of x? The derivative of root of x is 1 over 2 root x times 4.
Oh wait,
So
can you go
this is
back?
2 over, sorry, 1 second, 2 over root x, with x equal to 1. The answer is 2.
What does that say?
Guys, so not, you see, you don't need to copy what I did. You see, don't copy the particular problem. Do you understand the idea? I just look at it and I say two things. Well, why is the limit not immediate, right? So look at it and you see that the limit is infinity multiplied by something that looks like infinity minus infinity. So it's like infinity times 0, right? Every time you see a complicated limit, you right away think maybe there is a derivative in disguise. So many of you solved problems on my exam using L'Hopital's rule, which I'm not sure if you knew what L'Hopital rule is, right? L'Hopital is a particular instance of recognizing the definition of derivative, right?
So it's
It's
just
very
4?
sad to me that people use L'Hopital and not recognize that it's just a definition of derivative. So this can be used by, you can use L'Hopital here, but that's a waste of energy. It's like a particular recognition of derivative rather than a general one. Do you understand? Why does L'Hopital work? It's because it just recognizes that the limit means the same thing as if you were to take the derivative. Good. You have any other questions before we end, Christian, for today?
We'll end it here.
Okay. Did you like the Human Giant episode? It was my favorite show here. I can show you maybe next time. I'll show you my favorite sketch. All right, so then I suppose goodbye. I'll see you tomorrow.
Thank you. Have a good day.
Well,
Thank
my
you.
favorite show that was American here, right? It's not my favorite show, but whatever is, yes. All right, take care, guys. Enjoy your time. Goodbye. Auf Wiedersehen. Take care. Take care, Edwin. Helene, goodbye. I'm stopping the recording.